My name is Haley Harmon, and this video is about the explosive pentatereerythritol tetranitrate, also known as PETN. PETN is a highly explosive organic compound composed of carbons, nitrogens, and oxygens. This explosive compound is formed by reacting pentatereerythritol, C5H12O4, with nitric acid, HNO3. Now that you know what PETN is composed of, how does it form? Shown here are the reactants for the production of pentatereerythritol and water. There is a distribution in charges in each of the reactants. In pentatereerythritol, oxygens are connected to carbons and hydrogens. Oxygen is a lot more electronegative than both carbon and hydrogen. This will allow it to pull the electrons from both the carbon and the hydrogen closer to itself. Since it will then have all of those electrons from within those bonds, predominantly with the oxygen, it will have a negative dipole. Since the electrons from the carbon and hydrogen are being pulled away from them, the carbon and the hydrogen will both have positive dipoles. The same follows with nitric acid. Since oxygen is more electronegative than nitrogen and hydrogen, it will predominantly pull those electrons from within the bond, giving the oxygen once again a negative dipole. Because these bonds are being stripped from the nitrogen and the hydrogen and the hydrogen will both have positive dipoles. According to Coulomb's law, the negative charges are going to attract. The varying electronegative oxygen in pentatereerythritol is going to be attracted to the positively charged nitrogen in nitric acid. This attraction is going to form a bond between pentatereerythritol and nitric acid. The compound that is formed can be called the transition state. This is when no bonds have been formed and no bonds have been broken. Both of the reactants are connected, but this is very unstable. A bond is going to be formed between the oxygen and pentatereerythritol and the nitrogen and nitric acid. The nitrogen and nitric acid will then have 5 bonds. This is very unstable for nitrogen. It is going to want to break one of those bonds. It will break the bond between the nitrogen and the hydroxide group. The electrons will remain with the oxygen because it is more electronegative. The same occurs within pentatereerythritol with the oxygen that just formed with nitrogen. This oxygen now has 3 bonds, which is also unstable. Therefore, it is going to break the bond between the oxygen and the hydrogen. The electrons will stay with the oxygen because it is more electronegative. Eventually, the hydroxide group lost from nitric acid and the hydrogen lost from pentatereerythritol will form a bond to make water. Once these steps have occurred, you will have your final products, pentatereerythritol tetranitrate and water. The background of PETN is somewhat significant when talking about why it is important to us today. PETN was first manufactured in 1984 in Cologne, Germany. It went into full production in 1912 and was used by the German military in World War I. Still not seeing why this is important? Well, it's important because this explosive is still used today. It is not hard to find, and it's not that hard to make, which makes it very popular among terrorists. It cannot be detected by screening machines in airports, which makes it dangerous for us who fly on these planes, where this explosive can easily be concealed within someone's sock. Small amounts of this explosive have very large effects. And even though it was manufactured a long time ago, it's still just as dangerous as it was back then. This explosive was used in war. PETN is detonated with a shock wave or heat. The nitrogen groups in pentatereerythritol tetranitrate are very unstable. The lack of stability arises from the amount of energy in the final product of pentatereerythritol tetranitrate. When producing the product, the reaction undergoes an endothermic reaction, adding energy into the system. However, this makes it very unstable since the energy has nowhere to go. Once it is ignited, an exothermic reaction occurs to release all of the energy that is built up in the product, and an explosion occurs. PETN is detonated with a shock wave or heat. The nitrogen groups in pentatererythritol tetranitrate are very unstable. The lack of stability arises from the amount of energy in the final product of pentatererythritol tetranitrate. When producing the product, the reaction undergoes an endothermic reaction, adding energy into the system. This also adds to the lack of stability of pentatererythritol tetranitrate. Once the explosion occurs, the products from the explosion, CO2, H2O, and NO2, are very strong and stable. This will then classify the explosion as exothermic. To sum it up, pentatererythritol tetranitrate has very weak and unstable bonds. Since molecules more or less want to be stable, pentatererythritol will react or explode to become more stable.